Hello students, today we are going to discuss about types of magnetic material. This class is for third semester electrical engineering diploma students, and we will now discuss about types of magnetic material. In the previous class we have already discussed what are the magnetic material, and in today we will discuss about their classification of magnetic materials. First, we are going to discuss about your diamagnetic materials. Diamagnetic materials. These are the materials in which it bears the property in which the magnetic moment is opposed or moves in the opposite direction of magnetic field. In case of diamagnetic materials, the phenomena by which the EMF, the induced magnetic moment, the magnetic moment induced in the diamagnetic material is always in the opposite direction of the applied magnetic field. In case of diamagnetic material, the induced magnetic moment is always in the opposite direction of the applied magnetic field. Here I can take the example. If magnetic field is in this direction, if we are applying the magnetic field in this direction, then the magnetic induced moment, the magnetic moment moves in this direction, in opposite direction in case of diamagnetic material. In case of diamagnetic material, the induced magnetic moment is always in the opposite direction of applied magnetic field. And in case of diamagnetic material having negative susceptibility, these have the negative susceptibility, is called a diamagnetic material. Further, for the diamagnetic material, each atom has no permanent magnetic moment. In case of diamagnetic material, each atom has no certain permanent magnetic moment. Next, going for your diamagnetic materials, we will discuss about the number of orientations of electronic orbits, which is we can call the outermost orbit, is an atom of the diamagnetic material is such that the vector sum of magnetic moment is 0. In case of diamagnetic material, the number of orientation of electronic orbits in an atom of the diamagnetic materials is such that the vector sum of the magnetic moment is equal to 0. The external field, here you can see the external field will cause a rotation of action on the individual electronic orbits. This produces an induced magnetic moment which is in direction of opposite to the magnetic field, and hence it tends to decrease the magnetic induction present in an specimen. If you are taking a specimen, if you are taking an example of the diamagnetic materials, then in the applied induced magnetic moment moves to the opposite of the magnetic field applied to the specimen, or it tends to decrease the magnetic induction present in the present in the specimen. Next, going to the next point, the ordinary material which has no repulsion or attraction of magnetic flux of lines when it is placed in a uniform magnetic field, but there is a repulsion of magnetic flux from the center of the material, indicating the diamagnetic behavior of the material. If we will try to in non-magnetizing material to get magnetized, we have to place it between magnetic field. Then a force of repulsion or attraction for the magnetic flux is induced. Flux is line when displaced in a uniform magnetic field, but there is a repulsion of magnetic flux from the center of the material, indicating the diamagnetic behavior of a material. Next we will show that the diamagnetic material repel magnetic lines of force. Here you can see, if magnetic field is applied in this direction, then the magnetic movement, induced magnetic movement will move in this direction, which this property bears the diamagnetic material. This is called the diamagnetism property of a magnetic material. Diamagnetic materials repel magnetic lines of force. Repel, when if the magnetic lines of force moves in this direction, then the diamagnetic material moves in opposite direction. That is the basic property of a diamagnetic material. There are no permanent dipoles, consequently magnetic effects are very small. Very magnetic effects are small in case of diamagnetic materials. Generally, the value of a diamagnetic susceptibility is independent of temperature and applied magnetic field strength. These are the two factors, applied magnetic field strength and temperature. The susceptibility of a diamagnetic material is independent. That means it doesn't depend on these two factors, which is a temperature and a magnetic field strength. Next, we can take an example of organic material, light elements, alkali earths, bismuth, niobium, and these are the various examples of a diamagnetic material which exhibits the diamagnetic property of a magnetic material. Next, we are going to discuss about the paramagnetic materials. Paramagnetic materials. First of all, you have to know that what property it exhibits. A paramagnetic material, what property exhibits? The paramagnetism is the phenomena by which the orientations of magnetic movements are largely dependent on the temperature and the applied field. In case of diamagnetic material, we have previously discussed that it is independent of temperature and applied magnetic field. But in case of paramagnetic materials, it obeys the property, or it depends on the temperature and the applied magnetic field. Next, if the applied magnetic field energy is greater than the thermal energy, the magnetic movement of the material is finite and large. Then the number of orientations of a orbital and spin magnetic moments be such that the vector sum of the magnetic moment is not zero. But in case of diamagnetic material, the vector sum of the magnetic moment is become zero. But in case of ferromagnetic material, the vector sum is not zero, and there is a resultant magnetic moment in each atom, even in the absence of a applied field. Then, if we apply an external magnetic field, there is an enormous magnetic movement along the field direction, and the magnetic induction will increase in case of a paramagnetic materials. And in paramagnetic materials, it exhibits a force of attraction between the applied magnetic field and the induced magnetic lines of force, or induced magnetic moment. The paramagnetic materials attract magnetic lines of force. If we consider the direction of magnetic field, if we consider a magnet, let us consider, I am considering here a magnet. In this magnet, if the magnetic lines of force moves in this direction, then the induced magnetic moment will also moves in same direction. That implies in case of paramagnetic materials, the force of attraction exhibit between the paramagnetic materials and the magnetic field. But it attracts each other. Next, going to the next slide, we will observe that the value of the paramagnetic susceptibility are independent of applied magnetic field and depends greatly on temperature. In case of paramagnetic material, the value of susceptibility is greatly depends on temperature. We can say directly proportional to the temperature. Whereas, and we can represent the magnetic susceptibility x is equal to c t minus c by t minus theta. T is your temperature, where c is the Curie constant and theta is the Curie temperature. Curie temperature means we can say it is the highest temperature in which attains the magnetic susceptibility. In case of paramagnetic materials, the susceptibility is highly depends upon the temperature, and it is Curie temperature we can say. When the temperature T is less than the Curie temperature of the material, it is converted into diamagnetic. If we are converting a paramagnetic material into diamagnetic material, when the temperature T is less than the Curie temperature, then the material is converted to diamagnetic material. These materials are used in day-to-day life. The application of diamagnetic materials we can say in lasers, and one can create the required energy levels of transitions. Paramagnetic property of oxygen is used in nuclear magnetic resonance imaging, the instrument which is to be diagnose the brain tumor, blood clotting in the brain, and the etc. various medical applications in which these magnetic materials are helpful. Next, going to the examples of a paramagnetic material, you can say alkali metals such as sodium, potassium, and transition metals, chromium and yttrium. These are the example of a paramagnetic material. Next is your ferromagnetic material. Ferromagnetic material is further divided, that is ferrimagnetic, ferromagnetic. But we will now focus on ferromagnetic material and their properties. The ferromagnetic materials, we can say that is a strong force of attraction between the magnetic field and the magnetic moment. You can say it is strongly attraction forces exhibit. The ferromagnetism is a phenomenon by which the spontaneous magnetization occurs in case of ferromagnetism. Even in the absence of a applied field, then the magnetic moment are enormous. Ferromagnetism arises when the exchange energy is favorable for the spin alignment. If the magnetic field is applied in a material in this direction, and the magnetic moment also moves in, and there is a strong force of attraction, strongly force of attraction, strongly bonded or attached, we can say. It is strongly bonded or strongly attached in case of ferromagnetic materials. Ferromagnetism arises when the exchange of energy is favorable for spin alignment. If a material acquires a relatively high magnetization in a weak field, then it is not a paramagnetic material. Magnitude of susceptibility is very large and positive. When temperature is greater than Curie point, then it converted into a paramagnetic material. We have already previously discussed that when the temperature is less than the Curie point, a paramagnetic material is converted to a diamagnetic material. But in this case, when the temperature is, here you can see the temperature is greater than the Curie point, the Curie temperature Tc is the Curie temperature. When the temperature is greater than the Curie point, then it is converted into paramagnetic materials. These are all about your diamagnetic, ferromagnetic and paramagnetic materials. this we will complete the types of magnetic materials, and we will continue with the same chapter in the next video. Thank you all.